Um, all of you can hear me? All of you can hear me?
Yes, sir.
Okay, fine. Yeah. All right. So good evening, all. First of all, thank you so much, OP sir, for providing such an opportunity to present in this FDP. Uh, so, um, so today's topic that I selected for the discussion is speech technologies for healthcare applications. Okay, so yesterday it's more or less like a dysarthric speech processing that we have seen yesterday by Professor Prashant Kumar Ghosh from IAC. So here the difference is that yesterday's dysarthric speech processing was actually from the perspective of ALS and Parkinson disease, patients. So he was actually describing methods for the processing of speech collected from ALS and PD patients. But in this particular talk, I'll be discussing the methodology that we are actually using for or proposed to use for dysarthric speech processing from the brain stroke perspective. So that means we are proposing certain methods for the enhancing and the detection of severity from the utterances recorded from patients suffering from brain stroke, various brain stroke conditions. Okay, so I will just give so an overview of this particular talk. Is this talk is centered around our recently recommended ICMR project. This is the project actually. So here it is the title of the project is development of a unified analysis tools for severity assessment and enhancement of neurologic speech impairments due to various stroke conditions. So this particular since it is recommended very recently, so most of the works are actually under development. So we are in the stage of data collection. So this project is the implementation of this project is supported by All India Institute of Medical Science, Mangalagiri. So we have an AIMS here, very close by, around 5 minutes from our institute. So we are so all these clinical trials, then clinical data collection and the testing of the systems or proposed systems as a part of this project are actually proposed to be done from under the supervision of the doctors from AIMS. So with in this regard, I acknowledge the support, the immense support given by Dr. Rakesh Shuke, who is a professor and head of Department of General Medicine, where of AIMS Mangalagiri, where all these stroke patients are getting treatment from. And also, so this data collection or the clinical trials that are actually proposed in this particular project is a part of is being carried out from the stroke ward of Department of General Medicine. Okay, so then and also we have associated with again as a part of this particular project as with the Department of Community and Family Medicine with the support of Dr. Rajiv Aravindakshan, who is actually the professor and head of this CFM. In short, it is called CFM of AIMS Mangalagiri. Okay, so with so coming to the in-house team who is actually implementing this particular project is the speech research group at KL University, Vijayawada. So we have two campuses basically. One is at Vijayawada, which is actually in the Andhra Pradesh. So now it is the capital city of Andhra Pradesh. Then we have another campus in Telangana, which is in Hyderabad. Okay, so so this project is being implemented in at the speech research group of KL University. So our so there are 4 faculty members are actually involved in this in this group. These members are actually not a stranger to you, so you know them. So myself, then Professor Suryakant V. Gangasheti, who is actually the head of the speech research group here. Then Professor Samdri Vijaya, you all know him. 2 days back, he had given a talk in this FTP. And also Dr. Akhilesh Kumar Dubey. So he is also, he has graduated from, under the supervision of Professor S.R. Mahadeva Prasanna from IIT Guwahati. So his area was also in healthcare, the speech processing of healthcare, where he was actually working with various analysis of the hypernasality in cleft lip palate speech. So, and also from the KL Hyderabad side, we have a research speech research group. It is actually consisting of Dr. Ganga Mohan, who graduated from so under the supervision of Suryakant Gangasheti from IIT Hyderabad. Then Dr. Sandeep Reddy, who has graduated PhD from IIT Kanpur under the supervision of Professor Rajesh Hegde. Then Dr. Vishala completed PhD from IIT Hyderabad under the supervision of Professor Yagna Narayana. Then Botsa Kishore, who submitted his thesis so with the supervision of recently under the supervision of Suryakant V. Gangasheti. Okay, so this is the group, speech research group that KL University has. So it's a big group. Okay, so we are doing a lot of activities. We have few projects here, so I'll be discussing about it. So coming to this project, so the HMR project has mainly two objectives. So first objective is actually these objectives are actually uh, defined from two angles, the two perspectives. So one is actually clinician's perspective and patient's perspective. So when it comes to clinician's perspective, so so it is actually clinician-led self-assessment of the stroke. So generally, what is happening is the when somebody is suffering from stroke, so they will be approaching the clinician. So clinician will be doing some sort of assessment, medical diagnosis uh, of that patient, and so he will be assessing the impact of the stroke in some scale. So we have seen yesterday for ALS patients, there is a scale. Okay, similarly there is the scale used for assessing the stroke as well. So I'll be describing about that particular scale later, and also from the patient's perspective, it is all about improving the quality of life of patients. So most of the cases, when a person is suffering from stroke, his most of the cases, 95% of the cases, as the doctors say, the speech will be impaired. So there will be voice impairments. So which makes them, handicapped for using certain tools such as Google, some speech tools that we are actually using in our day-to-day lives, like Google Translate, speech translators, then Siri, and so on. So the idea the behind this particular module is actually from the patient's perspective is to improve their quality, enhance their voice, enable them to or empower them to use these kind of tools that other healthy people are actually commonly using in their lives. So that is the basic objectives of this particular the project. So this particular talk will be so so I'll be glancing through these kind of these two modules. Basically, no substantial work has not been done since we have started this particular project very recently, 6 months back, still in the process of data collection. So coming to the people the PhD students involved in this particular project, I should acknowledge them. So if I'm not doing that, it will be inappropriate because we are getting immense support from our students. So the person, so all these students are actually supporting us in various levels. Especially the hardest part is actually the collection of data. So going to hospital with all these devices and get the record the data, and come back to lab and listen to what they have recorded, curate it, you know, segregate it accurately, label them. So all these things are actually these students are actually doing. The first person is actually who is responsible, whose PhD is actually on the development of dysarthric speech corpus, and its analysis is Ondrila Banerjee. She is working with me, and Jyoti is being guided by Professor Samudra Vijaya. So the role of her PhD will be on in the development of ASR systems, or improving the quality, I mean, improving or reducing the wear error rates of ASR systems when we are actually developing, speak acoustic models for recognizing the words spoken by these patients, stroke patients, for the utterances that we have collected from the clinic. And also the third person is Lakshmi. Again, has been guided by Professor Samudra Vijaya. So she will be working on the phonetic aspects of the uh, the the prompts that we are actually using for collecting. So all these prompts that we are using for recording are in Telugu, and she is using some common label set for designing to bring some phonetic balance in designing these prompts. And also acoustic analysis will be done as a part of her PhD. Then Sirisha will be working on the hypernasality, analysis of the hypernasality. Currently, her topic is actually analysis of hypernasality in CLP speech. But as we know that, as Professor Prashanta sir has discussed in yesterday's talk, that hypernasality is one of the common symptoms in neurological, the speech recorded from neurological, patients affected by neurological conditions. So this hey, she is also planning to extend that work what she has done for CLP to this stroke case as well. And also the Ram Babu recently joined for PhD with us, and his topic that we have defined as analyzing the progression of the treatment in stroke. So when a patient comes for the assessment, first get it assessed, the impact of the stroke for the first time, then go back, he will be be given some sort of medicine, and doctors will be suggesting a follow-up visit after 3-4 months. So at that time, so what we do is that we'll be collecting the speech for the follow-up, and we'll be analyzing the speech parameters. How is there any progression? Whether this progression is actually aligned with the observed, the speech parameters with respect to the assessment made by the clinician. So this is what Ram Babu will be doing. So other scholars, those who are not a part of this project, is are Rama Rajeshwari. So we also have another project. We are a consortium partner of a partner institute of Bhashini. So here our role is actually to develop tools for speech quality control. So Rama Rajeshwari is actually working with Professor Suryakant Vigangajitu, who is actually the PI for this Bhashini project. So the topic is actually she is supposed to develop tools for automatically assessing the speech quality. So which is there are so many vendors are there, so many startup companies are actually giving us data. So she's supposed to automatically assess the quality. So at the signal level, at the prompts level, etc. And also we have recently joined part-time PhD student as Mr. Rituraj Gaikwad, who is working in CDAC Pune. So So he also will be developing ASR tools for the automatic assessment of speech quality controls. Especially, he'll be working on the correctness of the labels given by these vendors. Okay, so that is the so this is all about speech group. Coming to the organization of today's talk. So my talk is actually organized like this. So I'll be giving an introduction. Okay, so as far as possible, I tried to reduce the overlap between what we heard yesterday. Okay, so the introduction is also a little bit made with the perspective of the stroke, okay, brain stroke. Okay, so then I'll be again reiterating the objectives. So what I discussed earlier. Then so before we submitted this proposal, so we did the pilot study, so not on stroke, it is on TBI, a traumatic brain injury. So we took one TBI patient. TBI means so whenever somebody is actually getting a brain injury due to an accident, sometimes it may cause some sort of effect in their brain. Some part of the brain will be affected. It may not be due to stroke. Okay, so due to some accident, some trauma may happen in the brain, so that will in turn affect our speech production. So we come across one such patient, and we carried out some recording from the TBI patient. Okay, so then we did some basic analysis on this TBI patient, so that we took it as a case study, and based on the case study we developed a proof of concept. Okay, so basically what we do is that most of these medical projects, when we are collaboratively, when we do with the doctors, medical practitioners. So how it works is we have to get their confidence. So they work in a different way, and we as engineers, we are actually supposed to solve the medical problems from an engineering perspective. So basically the role of the engineers will be actually to work on the problems defined by the doctors. Okay, so for that we have to demonstrate so what we are actually trying to do here. So as a part of that, we have done this pilot study on this particular, by taking this as the case, and we developed the proof of concept based on that. So after that, we started working together as doctors. They used to come here in our lab, so we used to have common discussions. We used to write not only in stroke. Actually, we submitted various other proposals as well. So we do have some discussion. Basically, the idea is, doctors are defining the problems. As engineers, we are trying to find the solution for the problems that they are actually facing. I'll be just so summarizing or just glancing through some of the other problems that we are actually doing. So speech-based, so which involves speech processing. Okay. So then coming to the current discussion. So this project is actually under development, and we'll be discussing about some basic some analysis that we have. All these are rudimentary analysis because the data collection is still in progress. So as of now, we have frozen one set of data which consists of 50 stroke patients and 50 healthy speakers, healthy controls. Okay, so with that we have started some sort of analysis, some detection, two class classification we have done. So these are the basic works we have actually that I will be presenting here. And also, so I'll be discussing at the end some of the other medical problems that is defined by the doctors, which requires speech analysis and speech processing. Okay, so yes, is there any question? Okay, so let me. So all of you can hear me, right? Any difficulty in following
Yes,
this?
it's fine.
Oh, fine. Okay. Okay. So coming to the introduction of this one. So this particular topic. So this topic falls under the general category of cognitive speech processing. So cognition is actually involved. So all of you know about how a speech is produced, right? So if yesterday Prashant sir was also discussing about it. So this is the general, that speech processing, a common speech engineer or a student who is actually studying speech processing will study first. Okay, so one of the first topics in a speech processing course will be this. So I'll just spend 1 or 2 minutes here. So how a speech is produced, basically a trivial problem now with the advances in the speech technology. The selection of the features, robust features, and all, it's a trivial problem now. So how speech is produced, the raw material for the speech production is air. So when the air pushes the comes to the lungs, is exerting some pressure at the bottom of the what is that vocal cords, it will start vibrating. So based on the type of phonation, so if you are actually producing a voiced speech, this vocal folds vibrate quasi periodically, in regular intervals of time, which gives a pitch, a fundamental period. Then that will be actually modulated by your vocal tract to get the speech. But most of the cases, when you are actually somebody is working in speaker recognition or speech recognition, they don't bother anything further about it. They don't think much about it. But when you are actually working in the medical aspect, healthcare aspects of speech, you should not ignore these things. So this cognitive aspects of speech processing. Okay, so when before the production of speech, basically what is happening is that there is a the thought process which is generated in your brain. Okay, and there are certain areas which are actually responsible to guide the various muscles, to for the speech production. So that has to be, has to be, studied properly how the brain functions during the speech production. So part of that was actually discussed or by in yesterday's talk. Okay, so he was Prashant sir was actually telling about ALS patients where there is a brain center. This thought is actually not in patients suffering from ALS conditions. So what is happening is the thought is not getting transferred to those muscles which are actually responsible for the speech production. So patients will not be able to, they are losing control over their speech. They cannot even produce certain speech, their voices. So this is what is going to happen. So this part is the cognition is very, very important when you are actually working with dysarthria or the patients with the voice impairments. So let us see what is actually happening there. So coming to the brain, so these are the basic the parts or the basic components which are actually there in your brain, which is responsible for the speech production. Okay, so there are two aspects here. So basically there are two basic components here. So one is a Broca's area, two areas, okay, in your cerebral cortex. Okay, so one is Broca's area, one is Wernicke's area. So Wernicke's area is actually, you can see that the location of these two areas here. So first comes here is the Wernicke's area. Then Wernicke's area will give some instruction to Broca's area, and some sort of vibrate. It will actually stimulate or send commands, neural commands to the motor cortex, which will drive, send instruction to the through the neuron connection to the various muscles which are involved in speech production. So as you can see that there are two cases here. So one is when you are reading something. Okay, so when something I am actually reading, what is happening is so I have to see something what is written there. So in that case, there is another area called visual cortex. So that will come into picture. So this will give some instructions. So this is what this letter. Okay, so Wernicke's areas responsible. The role of the Wernicke's area is actually comprehend what you see. Okay, so here the instruction is given to the Wernicke's area. So Wernicke's area is going to comprehend when I am actually seeing a letter A or A. So it is A. So letter is A. That is actually, that comprehension is actually made by this particular area. Okay, so once that comprehension is done, which will send this stimulate or send instructions to Broca's area. Broca's area stimulates the primary cortex, which will again controls the muscles responsible for the speech production. So, and in between these two, so this primary motor cortex and Broca's area, there are sort of language part also will be lying there. Okay, so then coming to when you are actually involving in a conversation, okay, where you are not seeing anything, you are not reading anything. So what is happening is you can see that there is no visual cortex there. Okay, so when you are actually in a conversation or a telephonic conversation, you are not seeing, your visual cortex is not coming into picture there. So instead of that, there is actually auditory cortex, who is actually giving instruction to, so which is somewhere lying here, will give some instruction to Wernicke's area. So Wernicke's area will comprehend what is being spoken, what is being heard. Um, from the speaker, the other speaker to whom he is actually conversing with. Okay, so the Wernicke's area is again send instruction to Broca's area, which in turn controls the motor cortex, which sends the commands to the muscles involved in speech production. So this is how the information flow happens. So anything happens in these areas will have some impact over your speech production. Okay, so the various other activities also will be lost. For example, as you can see that when somebody is getting a stroke in the right part of the brain, so what is going to happen is there will be the left part of your body will be paralyzed. You cannot, there will be the movement of this left part will be affected, and vice versa. If left part of the brain is affected, the right part is getting, sometimes both the parts will be affected. So these conditions are, in the case of stroke, it is called hemiparesis, hemiplegia. Okay, that means in case of both the all bodies actually getting affected. So it's called a hemiplegia. It's a severe condition. So these are the effect of so anything happening in this area will surely impact the speech production. Okay, so coming to this one, there are few cases which we as speech engineers, we can't do much of a thing. For example, if the stroke or the cells around the the part around the Wernicke's area is severely the cells around this Wernicke's area is affected by stroke or any other accident or something, the whole comprehension will be lost. So in that case, for example, if I am actually seeing this pen, okay, so your Wernicke's area is actually responsible for or make you understand that whatever is this particular structure or this particular object that you are actually seeing is pen. Okay, if that comprehension is lost, then it is a severe condition. So we can't do much of we don't have much solution there, so it will be very, very difficult. It's challenging situation and for the patients. Okay, so and the second part is when these area, Broca's area, or these auditory cortex areas are actually getting affected. Broca's area is actually getting affected. So these results in a severe condition. Generally, these conditions are actually known as the aphasia. Okay, so Wernicke's aphasia, we can't do anything. So it is very difficult, very challenging for to bring out some sort of engineering solution to that. Okay, as the doctors say. So in our, when we write proposals and all, doctors always ask, so what is the, when you're working, when you're proposing something for the stroke, then you have to include your, inclusive and exclusive conditions. So which one is has to be included and which one has to be excluded. Okay, so most of, in our cases, we have excluded most of the aphasia. Whenever the aphasia comes, it will be a little bit, for engineers, it will be very difficult to bring out some sort of solutions to the this one. So, so in this particular case, we are actually focusing only the dysarthria due to stroke. So I'll just give an example of what is a dysarthria and what is an aphasia. So there are few aphasia, especially in the Broca's, a mild aphasia can be, we can actually tackle that in some way. So I will actually show you one such thing. So I'll be playing out. Just let me know if you are hearing this. All of you are hearing this, what I'm playing?
No.
No,
No?
no, you have to share your audio.
I shared it. It is absolutely zero. Let me increase the volume. Now,
No, sir.
can you hear?
No.
Yes or no?
No, sir.
No. Maybe the second one. What about this?
Yes.
You can hear this.
Yes,
Okay, so I think, can you just close it, because the stroke patient is speaking very low voice. I will try to increase the volume here in my computer. Let me. So volume is high. Okay. Okay, just to listen to this. Probably I can actually try.
Yes, some sound has come.
Okay.
Maybe you can go ahead with the other one.
Yeah. So, what you have observed here. So, what is happening is there is a volunteer who is speaking. First of all, the volunteer is actually uh, telling the patient to repeat certain vowels. That is the initial part of the speech. Okay, so say ah, then patient will be telling ah. Okay, so in that particular voice quality, I think you have heard that. Okay, I assume that you have heard it. And when it comes to aphasia, so I don't know whether you can hear this.
మీ పేరేంటండి
అవి చిరంజీవి
మీరు ఎక్కడ
Can you hear?
Yes.
Can you hear this?
Yes, yes, we can hear.
Okay.
Play it.
చిరంజీవి దత్తపతి
మీరు ఏం చేస్తూ ఉంటారు
అవి చిరంజీవి దత్తపతి ఆమె
ఆవిడ ఎవరో తెలుసా
గోపి
ఓకే థ్యాంక్స్ మీ సమస్య ఏంటండి
అవి చిరంజీవి దత్తపతి
ఈ చెయ్యి మీకు పనిచేస్తుందా
అవి చిరంజీవి దత్తపతి ఆనంద గోపి ఎనర్జీవి కృష్ణ
మీరు ముందు ఏ పని చేసేవారు మీకు తెలుసా
అవి చిరంజీవి దత్తపతి అన్నయ్య గోపి చిరంజీవి దత్తపతి
Okay, if you have listened to this, can you tell me what is the difference between the first file that I have played and this file? Can anyone tell? Because first one which I played is an example of a dysarthria. The second one is an example of an aphasia. So anyone can have the, of course, you may not be knowing the language. So if you have listened to these patterns, so what you have observed there? Okay, what you can actually observe here is, in the first case, when the volunteer is asking the patient to speak out, to utter some words or some, vowels, the patient is actually, patient could utter that, right? So patient is also telling E, E. But in the second case, when in the aphasia case, whatever the volunteer is actually asking that particular patient, he is replying only one sentence. His name is some Setupati something. Okay, every question, for every different questions, the particular that patient is actually giving only one answer. Okay, the volunteer is changing various different types of questions, totally different question in various areas. Still the patient is able to provide only one answer. Only thing is that it is not, comprehension is not affected here for the patient, but the Broca's, it is a typical sort of a Broca's aphasia where the what is that the patient is actually losing the control over driving certain muscles. Okay, so he is scared of somehow the doctors are actually telling sometimes trauma may happen, so he'll be scared of producing different other all other sounds which are available in a language. Okay, so this is the basic difference between a dysarthria and aphasia. Let us listen to this another example of dysarthria, so you'll get to know. So in this case, you can see that this particular example which I played is a example of a dysarthric speech which has a slurred speech quality. The slurring is there, so he is speaking little bit in a slow manner, right? The same patient is actually speaking in this way. So he's speaking in Malayalam. So in this case, so these two are actually same patient. Okay, same patient, it is spoken, so he knew two languages. So he did not have any problem in producing sounds of two different languages. So this is a typical example of the dysarthria, condition of dysarthria, where he has difficulty in muscle movements, controlling the muscles. But he has not lost the total, brain has not lost the total control of the muscle movement, so he still can actually manage the speech. Okay, whereas in the case of aphasia, he is losing almost a total control. He doesn't have any control over what he is actually speaking, even though comprehension is there. Okay, so that is the difference. Okay, coming to the pilot study I'll be describing. So in the first part of the presentation is actually completed. So if you have any doubts, you can ask here. I'll try to answer. So anyone has any doubt? Any questions?
I think there is no doubt. I mean,
Okay, yeah.
Sir,
So
sir,
yeah,
Manda.
please.
Actually, sir,
Yeah.
these audios are very unclear. Na? So, what's a normal technique that we can use for extracting?
Actually, it's a good question. So probably you'll get an answer when I'm actually describing the next phase of my presentation. But as an answer to your one-line answer to your question, it depends on the voice quality that particular patient is having. So when a particular patient is getting any kind of neurological condition, it will, like yesterday's talk, Dr. Prashant Kumar Ghosh was actually playing some showing some sort of a chart where what type of voice qualities are actually different patients are getting. So accordingly we can actually suggest some sort of use certain techniques or speech processing methods to make that particular speech to the normal speech. Okay, and most of the cases it's all depends on the application, where we are, what we want to do. If it is a severity assessment application, we can use some sort of some normal feature extraction technique and use some advanced speech modeling to get the severity classification done. And if it is an enhancement, we have to use other parameters depending upon the quality that we have. Okay. So
Sir,
maybe, yeah.
sir, you told me that you have been collecting data sets. So you
Yeah.
will be categorizing this group into different. Is it like that, or you will be combining it together?
So that's what I'll be explaining, that what category, as of now, we are not categorizing anything. Only category we are actually doing is that, so what we are doing is we are going to the clinic, we'll be selecting or recruiting the patient for our study. Then like yesterday, Prashanta sir has shown one setup, right? So we don't have a setup in names, but what we do is that we are going to ward and we are collecting data. At the same time, what we do is that we are recruiting this patient based on the reference given by the doctors. So the doctors are actually doing some sort of assessment. For example, yesterday for the ALS patients, so there is an assessment scale that they are using, some ALS RS or something. And for the PD patient, they are using UPDR scale. So similarly, for the stroke also, the clinicians do some sort of assessment to check the impact of stroke. Okay, it is called a NIHS score. Okay, so NIH stroke scale. So on the NIH stroke scale, so they will be putting some number. So if the number is above some value, we can call this particular patient having mild stroke. If it is between this number and this number, it will be moderate to severe, and severe categories. Okay, so that is the only categorization we are actually doing.
Okay, thank you.
Okay, yeah. So let me proceed with my presentation. So please stop me whenever you have any doubt. Okay, coming to, so like I said, so we started entering into the in the speech processing for the stroke, the voice or dysarthric speech processing for stroke patient. We conducted a pilot study, which was not in stroke, which was on TBI patient, traumatic brain injury. So this work, so we developed a proof of concept based on the study we conducted here. So it is on the speech enhancement. Okay, so this study was actually presented last year, 2 years back in 2023, the speech and computer, the conference in speech and computer. So these work has been done, collaboratively with doctors. So not from AIMS, of course, they were also a part of that. So we are consulting them for getting some help with respect to the diagnosis part. Okay, so here, so we met with this particular patient who was actually getting treatment in one of the stroke or neuro rehabilitation or stroke rehabilitation center in Kerala. So you can see that Professor Suryakant is there. So who is actually involved? He is actually the volunteer. He played the role of volunteer. So I recorded casually. I just recorded in our mobile phone. So this is the quality that we are actually getting. So you can see, closely listen to what happened to him was he was a chef in one of the hotels abroad. So while he visited his native place during the vacation, so at that time he met with an accident and he suffered a brain injury. Okay, and it was happen. So the brain injury was in the form of a blood clot in the cerebrum. So it was quite near to the speech areas, though it was not resulted in sort of aphasia, but it was actually affecting the motor cortex. Okay, so as per the assessment, he was actually by the neurologist. They did some sort of cognitive assessment, okay, test on him, and he was actually, so these are the two cognitive assessment tests that he was subjected to, and based on these two tests, he was actually diagnosed with mild cognitive impairments. Okay, so this is the quality that the speech quality that the you can get to know when you listen to this. You can get to know the type of voice quality he has. He was having a slur speech quality. You can listen to this. So can you hear this?
Kerala?
Yes.
You are from Kerala?
From Kerala.
Alpe.
I'll be.
Which year you went there? To Boston? To abroad? When you went? 2010, 15, 20?
Every year.
Ah,
I just go to the
then
just be.
13.
Uh,
Oh, good.
I just go to
Ah,
I go.
So you could listen to the voice quality of this patient.
Yes.
Okay, so you can see that he has a lot of slurring. He's speaking very, very slow. So as a result of that, it is the doctors are telling that it is difficult to have a normal conversation with him. So whatever he's speaking, it is we can understand that. But only thing is that we have to put a lot of effort in understanding what he is speaking. So it's called a listening effort. So the idea, so the first, since he was actually slurring, since he is speaking too slow, the first idea that came to us was, okay, is it possible to make his speech fast by the speech techniques that we have? Okay, so there are so many tools are available here, which do the the duration modification. So we have Pisola techniques and so many other techniques are there. So which by keeping the naturalness of the utterances, we can actually make the speech fast or slow. Okay, so the idea that when we listen to this particular while discussing, the idea came to our mind was, is it possible? What will happen if we apply a duration modification algorithm here? Okay, is it possible to reduce the listening effort in some way? So, and also we did so we had this recordings of this conversation in 3 different languages. One is his native. He was a native speaker of Kerala, so he speaks Malayalam. Then that was his L1. Then he speaks English fluently, then Hindi also, but the Hindi was not that fluent. Okay, so what we did was we did a basic analysis of the recording that we have collected from him. Then so we compared, so we kept our Suryakant sir's voice as the healthy speakers because he was actually the volunteer. So you can see that when we plot the pitch contour, so you can see that it is almost flat for the same sort of syllable, okay, or same sort of vowel part. You can see that the healthy speaker's voice is actually, you can see certain variations here. So it is not monotonous, but in this particular case, it is monotonous. So I'm referring to the yesterday's talk by Dr. Prashanta, that towards the end, he was actually telling about the significance of using what is a pitch alone for the classification of severity, or for the tasks he has actually. So the 2 class problems that he was mentioning, and mild moderate classification, severity classification of ALS and PD patients. So you can see that pitch is a prominent feature here, so that we have understood, so that we can see here. And also you can see that when you are actually doing some sort of the basic the word count, okay, at the first level, you can see that compared to the healthy speaker, the patient is the TBA patient is having is speaking quite slow. Okay, so the idea that we were trying to use here was the duration modification algorithm. So we have developed in our lab, so while doing PhD, so we have developed epoch-based duration modification methods. Okay, so that we have applied here. So it was actually showing some sort of encouraging result. So you can see that. So if you want to know about more about time scaling of speech, you can actually refer to the paper that is actually given at the bottom. So it is our own paper. So you can actually, it was published in 2010 in Speech Prosody conference. So you can, those who are actually interested, you can refer the details that I'm actually, the more details about this in this particular paper. All right. So I can just play out some of the samples. This is the original one. So this is the original utterance that we have selected a segment. So we have segmented the speech raw recording that we have collected from him. Then we applied the time scaling on this utterance. Okay, so you can see that at the first level, when you listen, we feel that of course there are some noise there. It's the processing distortion, because the recordings that we carried out, there were fan noise and other noises. It was in a clinic, as you can see in the video. So all those things will get enhanced. We have to do some sort of an post processing for enhancing those voice. So coming to this, the Malayalam part. So So when you see that both the samples of the time scaled versions of his speech, you can see that it is there is a significant improvement. Okay, how far it is actually improved, we have to assess that how good our time scaling is. For that, what we did was we did a kind of we carried out a perceptual evaluation. It is actually based on the mean opinion scores. So in this case, what we did was we thought of conducting this particular perceptual evaluation among the doctors, because this is a patient and we are actually, as an engineer, we are actually bringing the solution. So it is so anyway, finally the patients have to use this on the instructions of the doctors. So we thought of let this algorithm be evaluated by the doctors. Okay, and these are the scales that we have given to them. So when you are actually properly, so if it is clear, clearly you can actually understand without any effort, you can understand what is speaking just like a normal healthy speaker, then you provide a score of 5. Else you can actually provide, so if it is less than that, you can actually provide a score of 4. If you feel that it is disturbing the listening effort due to certain processing distortion, then you can actually give a 3. So accordingly, if you can't listen anything and it is actually affecting the naturalness totally or intelligibility, then you can actually provide a score of 1. Okay, so accordingly, when we are actually did the study among the medical group, also we also did that. So both the groups, medical group and the non-medical groups, provided poor recognition. So when we are actually encoding the speech files that we have actually generated, we call it as stimuli for various factors of the duration. So various duration modification factors. And also we have included no modification, which is a modification factor of 1. That means the original samples were also included in the stimuli that to be evaluated. So while presenting to the subjects, okay. So when they evaluated it, as we have seen that for the no modification, so all of them unanimously provided low scores. Whereas when we are actually using the algorithm, the time scaling algorithm for a factor of 0.75, so it was found to give a better score. Okay, better perceptual score. It is actually the mean opinion scores, a mean of around 15 subjects we have taken. So the mean is turned out to be better than what they have given for the no modification. And a similar trend was actually, even though the non-medical engineering students actually they generally provides in a biased way, but they provided a better score. But you can see that this is since there are two languages, the perceptual studies were categorized into two groups. One is for the Malayalam medical group and non-medical group, and English medical and non-medical group. Okay, so this is what is there for Malayalam, and this is for English. So both the languages, so independent of the language, so we found that time scaling of the speech is working. Okay, so it is successful in improving the perceptual quality to some extent. Okay, so and also we have found during this study we found some interesting results, such as the Malayalam listeners, the native Malayalam speakers, they were tending to provide a better score when they listen to their English. Okay, because of the accent. So in their mind they can actually read out without much effort, they can actually understand. But if some other language person is listening to the English, they felt a little bit difficulty. So these are some of the supplementary results that we got out of this study. So the bottom line is, so time scaling is working, and the optimal time scale factor that based on the perceptual evaluation are found to be 0.75. We reduce if we have a 1 second dysarthric or slurred quality speech, if you're actually making it 0.75 seconds, making it fast. Okay, so it will improve the perceptual quality. Okay, or it will improve the intelligibility in some way. That is the result of this particular perceptual study. Okay, so based on that we have, so to what extent we can, so what? Okay, so we found that it is improving. Okay, so what? Okay, so what is the next step? So what we do with that? Okay, so is it possible to bring out some sort of a proof of concept to make it work for certain applications? Okay, so what we thought was, actually, can we try this non-modified speech segments that we collected from patient to make our normal what is that speech translators that we are actually using, like Google Translate or Siri. Can we give it them as input? Is there any visible changes that we can actually observe there? Okay, whether both the cases it is does the Google Translate is powerful enough to take any sort of distorted speech to give the correct answer? Is it so? So we have to test that. So with that case, we have tested with that thing in mind. We tried to give this particular modified speech, time scaled speech and non-time scaled speech, or non-modified speech to the Google Translate application. So you can see that. So this is the application.
Is made to demonstrate how patients with voice impairments as utterance collected from a patient who affected with a condition known as diffuse axonal injury. So this is a demonstration. So what we are actually trying to show to speech translation system. So when somebody is speaking in a particular language, Google Translate. So here I'll show you how this application has to be used. So you can type in Google Translate. It will just show you this one. So here I have selected Malayalam as the input language, and the output is English. Okay, so I am going to record some voice, so the system will recognize what I spoke in Malayalam and it will convert to the target English. Okay, so what I'm trying to say is, എൻ്റെ വീട് കേരളത്തിലാണ്.
My home is in Kerala.
So you can see that എൻ്റെ വീട്, that is recognized, then it is converted to English. My home is in Kerala. So that is what the Google Translation application is. Now, what I'm going to do is that I'm going to, instead of my voice, I'm going to give the speech of the patient who suffered from this particular condition. Okay, so we have recorded. I'm going to play back since the patient is not here. I'm going to play back. I have already pre-recorded data. So this is the original speech.
Handing over.
So we'll try one more time.
Throwing Malayalam.
So we tried this, try to work on this application, but every time it was actually giving a different answer.
Okay, so what is happening?
बोल देना कल वो ले आएंगे घुगनी वाला
Yes.
छोला.
Hello, any question? If you don't have a question, please mute your mic. So the thing is that we were trying to test the Google Translate using the unmodified version of the patient's voice. That means the raw recording of the patient's voice. So when we try to use the Google Translate, it was failing miserably. So it is not picking the what is being spoken by the patient. Okay, and now we are actually presenting.
Now the same speech, we have modified the speech characteristics, okay, by an algorithm. So now I'm going to play that.
I know Malayalam very well. I know Malayalam very well.
So this is
So the idea is, so when the second time when we are presenting this recorded voice is the time scaled version of the recording. So the time scaling factor we used was 0.75, which was the outcome of the perceptual evaluation we conducted earlier. So this is actually the proof of concept that we have developed, that we are showing that we showed that by using a simple tool that speech processing engineers are actually familiar with. They are extensively using for various prosody modification applications or speech emotion synthesis applications. We can actually use it for this particular purpose to enhance the perceptual quality of speech. And by improving the perceptual quality of the impaired voice, or especially the slurred voice, so we can actually make the patients use certain applications like Google Translate, empower them to use comfortably, okay, with the help of these kind of application. That was the proof of concept that we have actually demonstrated. So of course there are extensively we have to study. So of course this particular study that we have conducted was for a single patient. So we have to extend this particular study for multiple patients. So with that idea, we approached the doctors. Okay, so this um, so we gave a presentation there with this particular proof of concept with this outcome of the pilot study. Okay, so they were all they were first of all excited by seeing the result. Then it is not a, of course, it is not a concrete result, but we can actually show as a proof of concept. Okay, then the doctor suggested that AIMS Mangalagiri, the speciality of AIMS Mangalagiri is that it is one of the hospital based stroke center. Okay, so after the COVID, so the stroke incident among the people are actually increased drastically. So as a result of that, based on the prevalence of this particular condition, okay, the ICMR, especially the NCDIR division of ICMR. NCDIR means their data collection division. So National Council for Data Information Retrieval. So they developed a they started a new program, stroke registry program. So they floated projects. So as a part of that, there are two what is that the two sources they brought out. One is actually for hospital. It is a hospital based center, okay, to collect the data, okay, and also the other center is just like a population based center for the people, okay. One is actually called HS what is that, hospital based stroke registry, HS what is that, HBSR something, and other is HBPR something, PBSR something, population based stroke center. Okay, so the difference here is that in the hospital based centers, so what they do is that all the treatment protocol, it is basically based on the doctors who are actually treating the stroke patients. So what they do is that they will they will upload the treatments, they will upload the diagnostic results that they are actually doing, or as a part of the treatment for the stroke patients. They'll be uploading, they will have a login, and they'll be uploading all these details, treatment protocols followed for a particular stroke patient, where exactly the stroke has occurred, which part of the brain, all those details, what type of test, what are the scans done, all these test results, everything, all the assessment that is carried out by the physicians or clinicians. So all these details of a particular patient will be uploaded. Okay, so there are in India, there are various HBSR centers available. So AIMS Mangalagiri is one among that. And also similarly, we have this population-based stroke register as well. So in India, there are 4 different centers, just like a Radar Kendra. So population, people can go give their data. So what happened? They can describe about their what is that about the stroke, how it developed, what was the symptoms earlier that was observed. All these details will be recorded. So ICMR will be getting data from both the patients directly from themselves and from the doctors and the treatment protocols. Okay, so then doctors were telling, especially Dr. Rakesh was actually telling, I have one stroke registry. I'm the PA for a stroke registry project where I'm actually treating the stroke patient. There are about 500 stroke patients are actually visiting him in a year. So why can't you? So we may not get enough samples for TBI. So you make it again, this 95% of the stroke patients will have this voice impairment. So why can't you just to make a proposal, so we can combinedly write a proposal for the severity assessment and enhancement of so voice impairments due to stroke. Okay, so in that way, that was the beginning of so our idea or motivation for writing a proposal for the processing of speech recorded from stroke patients. So that was the case. Then so we were coming to the ICMR project. So after we submitted this proposal, we went through several several iterations of several we gave several presentations in different the councils. There is IRC cell, Institute Research Cell, and IEC. So when it comes to the human trials, where the experiments involving human, we have to take IEC, the permission from the Institute Ethical Committee. So after a series of presentations, we have sanctioned with the IEC, and during that time, ICMR got recommended. We have submitted that IEC to the ICMR. They were okay with that. They released the fund. So this is the whole story behind this ICMR project. Coming to the implementation of this part, like I said, there are 2 parts. One is the severity assessment, and there is enhancement. Enhancement will be something like the one that I have explained earlier as a part of the pilot study. And in this case, so what we do is that what we are currently doing is actually so we have to develop certain methods for or certain protocols for the data collection. Okay, so in this particular stroke case, so like we have seen yesterday for the ALS case, so we have what ALS RS, some kind of a assessment scale where the ALS patients are actually assessed the impact of the disease. The doctors will assess based on this particular scale. In the case of PD patients, we are going for UPDRS scale. Okay, so how bad or how bad is actually this disease, how it is progressed. Those kind of assessment will be done by this by assessing based on this scale. So in the case of stroke, we are following a scale called NIH stroke scale. It is in short, it is known as NIHSS scale. So it is the total score of the NIH. It's a big. So I will show you. So these are it's a kind of questionnaire. So there will be doctors, clinicians will be asking various questions, and they will be assessing the what is that the various components of the so of the especially those who are actually involves movements, human parts involving the movements. So that will be assessed based in this particular, for example, level of consciousness. So what is the scale of that? How can you raise the hand, right hand, left hand, how far it is? So if the patient is telling I can actually little bit I can raise, so some score will be given. So total score is actually for an AHS is coming out to be about 45. So if a patient after the assessment is actually if his score is actually less than 4, in that case the patient will be assessed as having mild stroke. And if the patient, the NIHS score, total score is actually between 5 and 15, then his score will be, his category of the stroke will be having a moderate score. If it is greater than 15 and if it is lying in between 16 and 20, it is actually moderate to severe score. And 20, if it is greater than 20 and less than 45, okay, maximum score is 45, then that patient is actually in the severe category. Most of the cases, based on our experience, if the patient is having more than 20 NIHS score, he will not be able to speak properly. Okay, so in our data set so far, whatever we have collected, we haven't got any data corresponding to the severe category because they are unable to speak anything. Okay, so you can see that the speech part. So you can see the 10th component of the NHS score is actually the speech. So here the clinicians will be asking about if it is a whether you are able to speak. So if the patient is actually telling I don't have any problem in speaking, then the value is 0. Okay, so then if he is able to speak a little bit, then the value is 1, and if it is too severe. Okay, so that is the part here. So what we do is that in the case of NIHS score, so when we collect data from a patient, NIHS score will be the labels there. So based on the NIHS score, we are actually categorizing whether the speaker belongs to mild, moderate to severe, or the severe category. Okay, so this is the distribution of the speakers, for the 50 and 50 dysarthric patients that we have, collected so far. Okay, so still it is in progress. So for the subset of 50 patients and 50 healthy speakers. So this is the distribution of the various categories of samples that we have. Okay, as you can see that severe stroke, we don't have any samples because they're most of the higher NIHS score patients will have difficulty in speaking. Okay, so and also recording conditions, we are actually recording using multiple devices. Android mobile phones are actually used, and also we are using sound recorders. Zoom recorders are actually used here, and also in addition to that, there are certain cases we have dystonia, also facial dystonia, and also there will be vocal folds, impairments in the vocal cords. To assess that, we are actually using electroglottograph as well for the data collection. So that is actually separately recorded as a different set. Okay, so coming to the text forms to be recorded, there are 3 types of utterances we are actually using. So one is there are 5 vowels we are using: a, I, e, u, a, o, 5 vowels. Then 3 words which is actually involving transition between plosive consonants and the vowels: papa, pipi, pupu. Then you can see that 10 sentences are actually designed. So it is designed. So the language, most of the patients who are approaching the hospital, the aims is they speak Telugu. Some of them know Urdu. So the choice of our language is Telugu. So we are actually designing the prompts in Telugu. So So this we are using the common label set for designing the prompts used for the recording, and this chart is actually the distribution of the various labels. So we have designed in such a way that all these prompts are actually phonetically rich. So for all the 50 patients, we can see that all the sounds are actually available. Okay, and some of the sir, how much time I have, officer?
Hello.
Hello, how much time I have?
Actually, time is actually about to complete. So maybe
Maybe
within
2 minutes I
5 minutes.
will.
Yeah, wind up
Yeah,
actually.
yeah, I will just wind up. So,
Yes.
so this is about the data set. Now, some basic, I'll just glance through the analysis that we have actually done. So we have done some F0 analysis. We got some interesting results here. So with respect to the male speakers and the female speakers, and you can actually see that, the fractional F0 deviation, okay, for the male and the female speakers, especially with respect to the median. And yesterday, a similar result was actually shown in yesterday's talk by Dr. Prashanta, Ghosh. So he also shown a similar sort of analysis for the ALS and PD patient. So similar one we are actually getting. The idea is actually F0 is able to discriminate between the healthy controlled healthy speakers and stroke, the impaired patient or dysarthric patients. Okay, so this is one thing, and similarly, this is actually the MFCC features that we have used to discriminate, to develop a system to detect or discriminate between healthy speech and the dysarthric speech. And this is actually the test plot. Or even though there are overlaps between the two categories, but basic CNN will was actually showing some better discrimination, especially for the words papa, pipi, poo poo, was actually giving a better discrimination with the with the improved testing with the improved specificity, sensitivity, etc. Okay, so and the thing is that when you are doing this kind of studies for the sentences, because most of the patients were actually facing a lot of difficulty in completing certain sentences because of their stroke condition, because of the hemiparesis and hemiplegia, etc. So the sentences accuracy was actually a little bit low as compared to the vowel and word level for the what we got for the vowel and word level performance. Okay, so and also the reason one was the duration analysis. Likewise, so we have done a duration analysis. So we have done in terms of mean transition duration and mean transition area. So this is how we computed. It is actually the work, just an implementation of the work done by Professor Samudra Vijaya. So 2 decades ago. Okay, so we just applied to automatically estimating the transition, the durations of the dysarthric, patients and healthy speakers, especially in the transition regions. Okay, so this is how we compute the transition regions, and these the measures are actually brought. There are three measures. One is the mean transition duration and mean transition area. You can see that so the result that we obtained was the MTD or MTA, the mean transition area under the transition regions, was found to be found to discriminate between the healthy controls and the this dysarthric patients or stroke patients. Okay, so another one, I'll be concluding with this. The other medical problems that we are actually engaged at present is because these problems are defined by the medical experts, doctors. Are one is a speech-based severity detection that we are actually the detection for Parkinson's patients. We have submitted in one of the for one of the funding agencies, and it is under review. And the other one is sound-based subglottal secretion management system, so which is actually extensively used in ICUs. Okay, here it is called MCUs. So a sound-based by analyzing the sound, is it possible to set an alarm? Okay, and also there are objective markers for patients with depression and suicidal risk. This is actually written, a proposal was written in collaboration with the Department of Psychiatry at AIMS. They do some sort of, based on the voice, someone can actually say that you have a low confidence, you are feeling very low, and things like that. So these are all some of the works that we are actually engaged. So is there any questions? You can have one or two quick questions. Thank you so much for listening.